All right, so the stationary points refer to, all right, when they are maximum point or minimum point. Okay, we can find the stationary point when the differentiation is 0. Okay, now the second derivative test is what we are going to learn today. All right, so we are using the second differentiation to determine whether the point is a maximum point or minimum point. Okay, now this is what we do. Okay, now when we differentiate the second time and we substitute the value of x into the second differentiation, and if the answer we get is a positive answer, it shows that the point is minimum point and the curve is like this. Okay, and the curve like this, we have a minimum point and we say the graph is concave upward, concave up. Okay, the graph like this is called concave up. Okay, now similarly, if we differentiate the second time and we substitute the x into the function, we get negative answer. We know that the point is the maximum point because according to theory, the graph will be like this. All right, so the point is maximum point. Now, we call the graph concave down, right? If the graph is in this shape. Okay, any questions? Now, if you do not have any questions, right, let's continue with the next one. Okay, so now let's say we have a function f. This is a function f. So to find the stationary point, right, so first we differentiate. Now the f prime here means we differentiate. So after we differentiate and we let it be 0, so we can actually find the point, the x here. Okay, now let me write the steps. We have a function. Step 1, we differentiate the function. Now, after that, we let the function be 0. Right, we let the differentiated function be 0. And what do we want to do here? We want to find the x. What is the x? All right, when the slope is 0. Okay. Now, after that, after we have the x, all right, so we know this point. All right, let's say the x is c. Right, let's say the x is c. All right, at this point, right, we know it is a turning point or the stationary point. But we don't know whether this point is a maximum point or minimum point. So we are going to find the third step. All right, so the third step, we will actually find the second differentiation. And we substitute the c into the function. Okay, now, if we come to two situations here. Now, if the answer we get here, after we substitute the c into the second derivative, now if the answer we get is a positive function, then the graph is actually like this. Right, we say the graph is concave up. All right, and this point is the relative minimum point. Okay, any questions here? Student, are you with me?
Yes.
Okay, right, thank you. Now, after that, okay, we look at another situation. Now, another situation, still under this, after we substitute the c into the second derivative, if the c is a negative, okay, if the answer is a negative, second derivative is the negative answer, it shows that the graph is actually like this. And this point is actually the maximum point. Okay, the maximum point. And the graph is concave downward, we say. All right, like this is called concave down. So it's a relative maximum point. Okay, so we have two situations, right, when we substitute the c into the second derivative. Okay, now, all right, student, I want you to take note here, pay attention here, because we have a new situation. Now, if we substitute the c, it is not positive, it is not negative. So if it is not positive, not negative, what does that mean? Not positive, and it is not negative. What does that mean?
Zero.
It means 0. Good. So it means that it is a 0. So the third situation, if we substitute a c, we get a 0. Okay, we call this the inflection point. Okay, so the inflection point is when the slope on the left and right does not change. Okay, now usually when we get this one, after we get this one, after we get this point, here, the slope one, it will be one positive, one negative, right? The slope change, right? Or, right, at this point, right, the first derivative is 0. Now, consider the slope here. The slope is from negative to positive. Okay. Now, the slope always change after the turning point. Okay. Now, however, if the first derivative test we get 0, and the second derivative test we also get 0, it means that the slope of this point, left and right, all right, the slope still remain the same. We call this point inflection point. All right, so what is inflection point? The inflection point is when the slope between the slope on the left and on the right of this point still remain the same. Right, we call this point the inflection point. All right, so now the inflection point also is the point that when the concavity change. Okay, so now how many types of inflection point can it be? Okay, so it can be like this. One, all right, this point is the inflection point, one type. Okay. This is the one type. Another type is like this. Okay, concave up. After this point, concave down. All right, so this is also inflection point. All right, so it's actually the opposite of this. We just flip. Now, another type is like this. It's supposed to be, okay, the graph is supposed to be at coming to this point, and after this point, it should go up, right? It should go up, but the graph does not go up, the graph go down. Go down like this. Okay, it does not go up, but it go down. So you can see here, before this point, it's a concave upward, and after this point is concave downward. Okay, before this is concave up, concave. After this point is concave down. So the change of concavity. Is that okay? All right, now another one. Okay, will be something like this. It's the opposite. Okay, the graph go like this until here. I suppose the graph need to go down, but it doesn't. It goes up again. Okay, so this point is the divider. Before this is concave down. After this is concave up. So the concavity change at this point. All right, so let me erase this one. Oops. Okay, so we have 4 types of situation. All right, consider inflection. All right, consider inflection point. All right, the first situation like this is the inflection point. Second one is like this. The third one is this one. All right, and the fourth one is this one. Okay, there is a question here. Is it just the same sign of slope, or the value of the slope also the same? No, just the sign only. Okay, the slope is different. You can see here, let's say we take this as an example. At this point, the slope is like this. Okay. At this point, the slope is like this. So same slope or not? Not the same slope. But it's the same sign. Both are negative. Both are negative, but not the same value. Okay, so just the sign is the same. Okay, the sign is the same, but not the value. All right, so but take note, when I say the sign, it does not consider here. What I mean is this one and this one. Okay, it does not consider this one and this one. Okay, just all right, just right before this point, it will be negative to negative. It does not change the sign of the slope. Okay. Now let's take one example. All right, to understand the second derivative test better. Okay. Now find the extreme value of this function, 3x to the power of 5 minus 5x to the power of 3 plus 2. All right. So what should we do? Okay, I think just give me some time. I try to create one blank page so that we can do it together. All right, so now we start with this function. Fx equals to 3x to the power of 5 minus 5x to the power of 3 plus 2. Okay, students, so now we have this function. We want to find the relative extreme. What is this? This is the turning point, all right? Maximum point or minimum point. Okay, extreme point. So what should we do? Let's do some revision. Right. First, we find the differentiation. First derivative. Let it be 0 so that we can find the value of x. After that, find the second derivative. Substitute the x into it and to see whether it is a maximum point or a minimum point. Okay, so now first derivative. Okay, what do we get?
X to the power of 4.
Okay, good. 15 x to the power of 4 minus
15 square x square.
Good. 15x squared plus 0, right? We differentiate 2. What do we get? 0. Okay, so we have this is the first derivative test. Okay, now after that, what should we do?
Equals 0.
Good. All right, so let the first derivative equals to 0. So we have 15x to the power of 4 minus 15x squared is equals to 0. All right, so what is our objective here? We want to find the x. Okay. Right, so after that, what should I do here?
Simplify.
Simplify. So I factorize out the x square and
15.
Good. Right. Factorize. Take out the 15 and take out x squared. So I have x
Square minus 15.
minus 1, right?
Oh, yeah, right.
Right.
1.
Okay, so from here, all right, I know my x squared is 0 or x squared minus 1 is 0. And from here, if x squared minus 1 is 0, so x will be the
Negative
square root of 1. So it will be 1 or negative 1.
Yeah.
Negative.
Okay, so far, are you still okay with it?
Yes.
All right, good. Yeah, I heard a no.
Yeah,
Do you have any question?
For the from 50
Yeah.
x square. Yeah. I don't
Okay.
know.
We take out factorize. Factorize means that I have 15 here, right? And 15 here, right? So I take out the 15. So I have x power 4, x squared. So I take out x squared. All right, it's something like this. 15 x minus 15 x equals to 0. So now when we factorize, we take out the same thing. So this one, we take out. Oh, I have 15xx. This one's xx minus 1. Okay, so this one, after I take out everything, this is 1. So that when I multiply, I get back this one. 15x squared multiply here, I will get this. All right, so this one is x squared, and this one is x squared minus 1. Is that okay? Did I answer your question?
Yes, thank you, sir.
All right, thank you. So after
Sir.
that, yes.
Why is
Yes.
it not square root 1 and negative square root 1?
You mean here?
Yeah.
What is your question again? What you're asking? Why become 1 and negative 1?
Yeah, it's not square root 1 and negative square root 1.
It's not square root of 1 and negative square root of 1. This one, when I bring over here, it should be 1, right? So square, I bring over here, it will be square root. And square root, you know we are getting 2 answers, right? One is positive, and the other one is negative. Therefore, I have 2 answers here.
Okay. So just
Okay.
straight. Okay.
So now, for the value of x, I have 3 values here. Okay. If I start from the smallest value, it will be -1, 0, and 1. All right, so this is the value of x. Okay, any questions so far? Okay, next we are going to, now I know these 3 points, they are the turning point. Okay, or inflection point. But I don't know which one is which. All right, means that from here, 3 values here, I don't know which one is the maximum, which one is the minimum, and which one is the inflection point. All right, it can be all of them maximum or all of them minimum. Okay, so it can be anything. Okay, so now I'm in the following discussion, we want to determine, okay? In the following discussion, we want to determine. Okay, we want to determine the nature. Nature means that whether it is maximum or minimum. Nature means that maximum or minimum or inflection point. Okay, so what do? We are going to use the second derivative test. Now here comes the second derivative test. We use the second derivative, second differentiation. So how to find this one? We are going to differentiate from here. Okay, so can you provide me the answer?
60
60x3 minus
okay,
30x.
60. Sorry, a bit lag. 60 x power 3 minus
30x.
dx. Okay, thank you. All right, so this is the second derivative we have. So now we are going to test the value one by one. Okay, we put the value of x into the function, the second derivative, to test the value one by one. Okay, starting with x equals to -1. Now I'm finding the y first. All right, since I'm going to substitute this one, so I find the y also. Okay, can you find the y? Yeah, substitute here. Substitute here. What is the y? I have 3 -1 to the power of 5. -1 power 3 plus 2. So the y is, okay, I'm lazy. I just
4.
copy from here, 4. Okay, so I just copy from here. The y is 4. So I have the point now. Okay. The point is -1, 4. Okay, now I test on the second derivative. Substitute here. 60 -1 to the power of 3 minus 30 -1. And the answer I get is
-30.
-30. Okay, I check. Easy lah, I'll check from here. -30 lah. Okay, so the answer here. All right, this is less than 0. So what point is this point? What point is this point? The second derivative shows negative. It's a
Maximum point.
Yeah, good. So this is a maximum point, or we say relative maximum. Okay, it's a maximum point. And we can actually imagine that the graph is like this. Okay, this is the point. Is that okay? All right, so this point, -1, 4 is the maximum point. Okay, now, so same thing. Now, I'm going to test for the 0. So substitute 0 here. Okay. We let the x be 0. So 0. Okay, now, since we substitute 0 here and here, both get 0, right? Both get 0. Huh? So the second derivative when the x is 0 is 0, and the y is 2. Okay, now, when this is 0, what does that mean? Second derivative is 0.
Inflection point.
Yeah, it's an inflection point.
Inflection point, sorry.
Yeah, inflection point, correct. So it's an inflection point here, all right? So, means that now this is the inflection point. So we are going to write the inflection point. So it means that the concavity change, but the sign, all right, positive, negative, from the sign of the slope from the left and right of this point does not change, remain the same. And now I'm going to test the third point. Sorry, it's a positive one. Huh? So, okay, what is the y? Substitute 1 into here and here. All right, so I'll get 0. And substitute into the second derivative. All right, I will get 1 here, 1 here, so I get a positive answer. So this is more than 0. So, all right, concave up. This is a minimum point. All right, any questions? Yeah, before we proceed. Do you have any questions? Now, very quick one. Now I'm going to sketch the graph. Okay, we can actually use this to sketch the graph. Okay, so this is the graph. So I'm going to show it here. Now, first, let's say I have this is the x-axis, and this is the y-axis. Okay, no, not sure why I always hang. Okay, this is the y. Now, this point, -1, 4. So I can imagine it's somewhere here, -1, 4. All right, so to draw it higher, -1, 4. This point is the maximum point. So, all right, the graph will be like this. Okay, so I just leave it first, huh? All right. Now the second point is this point, 0 and 2. So when the x is 0, all right, the y is 2. It's about here. Okay, so it's here. And this point is the inflection point. Now, what does that mean? It means that this one is going down. Okay, all the way, going down until here. It's supposed to change the. Okay, it's supposed to change the inflection. It's supposed to change the sign. Right, means that it's go down like this. It's supposed to go up. Okay, turn, but it doesn't. It actually go down to here and go down again. Okay, now so go down again. And when we have this point, 0 and 2, is inflection point. And when we have this point, 1 and 0, 1 and 0 is here, 1 and 0. And this point is the minimum point. We have something like this. All right, so we have something like this here. Up and go down again. All right, so now, sorry that my drawing here is not very clear, right? The PowerPoint is not very sensitive. Now, however, this is the graph that we can get. So it will be something like this. All right, changing. All right, go down again, go up. Okay, so do you have any question on the second derivative test? Okay, there is a question here. Does the x we get always have 0? No, not necessary. This value here, sometimes you get some other value. It doesn't mean that the 0 is always here. Okay. All right, so now let's take a short break.